Good morning, Sam.
Hello, Michael.
Now, Sam, have you ever thought about the quantity of power needed to run a supercomputer?
I don't dwell on it, but I do imagine it is probably like tons and tons of gigawatts, maybe like a terawatt or something. You're a techie person. Do you know how much your home computer uses?
I think it uses about between 100 and 200 watts. Like, if it's really under load, maybe 300 watts, but like not a lot of energy. But Sam, today we are still in Bristol at the UK's fastest supercomputer to find out how you run a system of this magnitude in the most efficient way possible. I'm Michael Bird.
I'm Sam Jarrell, and welcome to Technology Now from HPE.
All right, well, welcome back to the second part of our episode pair exploring Isambard AI, the UK's fastest supercomputer. And don't worry if you missed the first episode, we will link to it in the show notes, but you can also watch both episodes independently.
Exactly. And because these are both video episodes, make sure to check us out wherever you watch your podcasts, and as well as wherever you listen to them. Now, Michael, you're still in Bristol for this episode, and I believe you mentioned that we're talking about efficiency today.
Yes, well, supercomputers use a lot of power and they can get out quite a lot of heat. So finding ways to reduce the power and to use the energy more efficiently can be just as much of a financial issue as a sustainability one.
Oh, for sure. And we've spoken about this before on the podcast, as well as doing episodes on things like heat reclamation from direct liquid cooling.
Yeah, and they use direct liquid cooling as part of their systems here at Isambard AI. But there's far more to running a facility like this than efficiency and cooling alone. So to find out more, I met up with Dr. Emma Rose, Centre Manager for the Bristol Centre for Supercomputing. The first thing I wanted to do was to get to grips with the scale of the power requirements for Isambard AI. Emma, we're stood in front of a panel with some information on it. Could you just tell me what we're looking at here?
Yeah, sure. We're standing in front of the building management system, which is effectively a panel that tells us how the modular data center is performing and all the cooling infrastructure around it. So you can see at the moment, all of the alerts on there are showing green, so everything is quite happy and healthy at the moment. But it's a really quick way for somebody inside here to see if there's anything wrong, because those green panels will turn to red. Also on here, we can see how much power the system is currently using. At the moment, it's about 2.4 megawatts of electricity is being used by Isambard AI. And we can also see the PUE, or power usage efficiency, which shows us the overheads that the cooling infrastructure uses of electricity over and above Isambard AI itself. It's particularly low, so it's 1.07, which means there's only 7% overhead for the cooling that is used to cool the GPUs.
So very efficient then.
Very, very, very efficient. In the past, the PUE for an air-cooled system would be closer to 2. So it's incredibly efficient.
Gosh, okay. And so, 2.4 megawatts is a lot of energy. I can't quite quantify that, but that's many, many houses.
Absolutely.
Where does the energy come from?
We pay for renewable energy, so it's all battery, wind, solar, hydro generated electricity from the UK.
Presumably that's slightly more expensive than buying non-renewable energy.
It is slightly more expensive, but it's important to us that we're using sustainably sourced electricity, because we're aware that we do use a lot and we want it to be as sustainable as possible.
How else are you managing power here? Like, what happens if there's a power cut? Does everything all the lights shut off and everyone goes home?
well, yes and no. So the GPUs in the room we're in now, in the event of a power cut, will shut down. 2.4 megawatts as it's using at the moment. There's no generators that would keep that sustained for long enough. We do have some critical systems on the site that we do need to keep going. The cooling, for instance, we would want to keep going in the event of a power cut. And we've also got some air-cooled equipment that ran us storage and our logins and management nodes. We need that to keep going, because if that shuts down suddenly, it does take a long time to bring it back up again. So we have a generator on the site that will keep it going for a few hours in the event of a power cut.
So we touched on the previous episode about all this water cooling. So how are you keeping this whole place cool?
So within the modular data center itself, there's big air conditioning units.
Yeah.
So the air around us is reasonably cool. But the GPUs, it's a closed loop system of a glycol water mixture that runs over the GPUs and extracts the heat, takes them out to the coolers outside. And then once it's been cooled by the coolers, it's returned back into the system again.
Hopefully it's still there. But these red and I open this store. These sort of red and blue pipes.
Yeah, absolutely. So the blue pipes are the cool liquid that's just come off the coolers. And when it runs through the GPUs, extracts the heat, and then it comes through on the red pipes there.
And then up and out of this room.
Absolutely, yes.
Okay. And I guess at this scale of computing, direct liquid cooling is really the only option here.
Absolutely, definitely. The only alternative is air cooled, and that's got some huge disadvantages in terms of sustainability. It would also mean that the system itself would take up about 8 times the space that we're using at the moment. So the system is very dense, densely packed in a relatively small area because it's direct liquid cooled.
So we're gonna head towards some of the plant stuff outside. Hopefully some of the water cooling bits and bobs. And is it just water in these pipes that's coming through?
It's a water glycol mix.
Okay.
So the glycol just provides an extra bit of coolant to absorb more of the heat. It also provides antifreeze properties. So if it got particularly cold, then the water's not going to freeze as it's out here.
Okay, and we're in the UK, so it gets coldish and hottish.
Yeah, it does.
Not super freezing, not super hot. But okay, so we're now coming across what looks like some very big, some very, very big panels and some very, very big fans. Can you describe what we are stood in between?
So we are standing next to one of our hybrid coolers. They're effectively very, very big radiators. So the coolant goes through some radiator pipes, and above them are 3 massive fans that pull in the air from above, and that cools the liquid as it runs through the radiator pipes.
Yeah, these look like massive car radiators and sort of funnels from ships at the top. So those are the fans. Those are the 3 fans up at the top, and these are the big radiators. And so all of the heat from the GPUs comes through here, comes through these radiators, and this is what cools the water.
That's right, yeah. So on a day like today, when it's there's a relatively cool wind, it's not a particularly hot day, then these coolers, they run in what we call dry mode. So we're not losing any water here. It's a closed loop. The coolant returns back to the system. If the outside temperature gets a bit hotter, then these radiators will start dripping water down the outside of them. That just provides a bit of extra cooling through evaporative cooling.
Okay. And so, I mean, how much energy are these fans, these radiators using?
So there's 2 coolers out here to cool the 2 sets of racks that we've got inside. Each one of them uses about 16 kilowatts of electricity if it's running at full capacity. Bear in mind that each side of Isambard AI will uses up to 2 megawatts. So 16 kilowatts to cool 2 megawatts worth of heat.
That's quite efficient.
It's
That's not a lot of energy. And so you talked about the water dripping down. I mean, it's a closed loop system, except for when it gets super hot. How much water is this system using in a typical year, maybe?
Because the UK doesn't get that hot,
Yeah.
we estimate that we would lose and drain away about 21 houses, the typical UK home's worth of water in a year. So if you think an average sort of cul-de-sac in a town with 21 houses in it, the amount of water that those 21 houses would use is roughly what we think we'd use in a year.
It's not loads of water.
No, not at all.
It's very much a closed loop system. Okay. So why did you go for a closed loop system? I mean, what other design options are there?
Well, really, at the moment, the only other design option is for an air-cooled system.
Okay.
So one of the other big advantages about using a closed-loop system is there's potential to reuse the heat. So we can harness the heat that's generated of Isambard AI and potentially heat surrounding buildings with that heat that's trapped in the water. If we use an air-cooled system, then that would just get lost into the atmosphere.
Okay. So there's a potential for that to be used, and presumably it's way more. I mean, it's way more efficient than air cooling.
Absolutely, way more efficient. I mean, we also have a chiller, and that's the cool. I talked earlier about the the critical systems, they are air cooled, and the chiller is to cool the environment around those. But that chiller alone uses more electricity than the 2 coolers that we've got. So
Wow, okay.
that gives you an idea just of the efficiency of those coolers. And
So super efficient. Okay, I do want to talk about sort of heat recovery. Can you go into it more detail? Like how does that work? How would that work?
So the liquid that comes off Isambard AI is roughly 40 degrees when it comes off the system. Heat recovery, we've got the pipework on site to be able to do this. You would need a heat pump to warm that up to about 70 degrees. And then if you have the infrastructure on the other side in a nearby building, then the heated up water or liquid can then go around and effectively warm up the buildings around it.
Wow, okay. So you can sort of become a bit of a utility to the buildings around.
Absolutely. It's done a lot in other countries. In Scandinavia, for instance, it's actually mandated by the government that data centers have to reuse their heat. So there's a lot of examples in other parts of the world where it's done a lot.
So do you think that sort of heat reuse would become, I don't know, in the UK, do you think the UK government would just mandate that for data centers like this, do you think?
I think they're probably going that way for anything that generates heat that can be reused. I think it's certainly moving in that direction. The problem is, at the moment, there's just not the infrastructure in nearby buildings. So some of that might involve retrofitting buildings. Some of it will involve putting that infrastructure in place when new buildings are being built.
Yeah, okay. Emma, thank you so much for your time. It's been a real pleasure having a look around the Isambard AI supercomputer, going around all the chillers. It's been fascinating. So thank you so much for your time.
You're very welcome.
You know, Michael, I'm very surprised that you were able to do this right in front of a supercomputer and it's not blaringly loud.
As I said in the interview, I'm quite used to being in like data centers or server rooms, and you're literally shouting. It's so loud because the screaming fans, I mean, they whine. But I mean, I'm stood next to a supercomputer that is running, and let me just put my microphone to it. Very underwhelming. It's basically silent. I mean, there's noise in here. There are other systems and fans and stuff running, but I mean, generally, it's pretty quiet here. You could have a conversation. So, yeah, it's amazing. It's quite incredible.
It is. And, I was also kind of surprised earlier in our conversation. I think I tossed out a figure like there's a terawatt of power potentially used. But to hear that there's only 2 megawatts of power, it's still a lot, but it's definitely less than I expected for a supercomputer.
I was really surprised with how low that number was. I definitely thought it would be like terawatts or gigawatts for the 11th fastest supercomputer in the world.
Definitely not what you think of when you think of supercomputers being very, very high energy consumption and like the sustainability angle. I think that's a wonderful story. I also think it was interesting to hear about the direct liquid cooling piece of all this. I believe that you all said that it's a closed loop.
Yeah, it's a closed loop. So they do use some water, as Emma said, in the summer when it's really, really hot. They do then sometimes use some water to help with the cooling, additional evaporation to help with the cooling. But it's not loads of water. I think it was the equivalent of like 21 homes, like how much 21 homes would use in a year, which, again, not an insignificant amount of water, but nowhere near as much as I was expecting.
Not at all. And if you think about it, like, there's a lot of things that definitely use more water than that. I imagine just like crops and to maintain like livestock somewhere, you probably use a lot more water. So comparatively, it's actually much less than I think the average person thinks about when they think of like supercomputing data centers, all of that. I hope we hear about other supercomputers and data centers trying to use a similar model. Now, you guys also did mention something about heat reclamation being in the works as well, which is also sort of plays into that whole sustainability loop.
If they do end up doing it, it's such a cool story. It'll be such a cool thing to do, to use essentially energy that's just at the moment not doing anything. If you can make use of that and do something intelligent, clever, useful with it, that's great. That's really, really great. And again, a model that could be used for other data centers. What did you think of going outside? What did you think of the all of the radiators outside? They were quite something, weren't they?
Yeah, I feel like the entire outside infrastructure area was huge, just like a lot bigger than I expected.
Yeah.
I suppose you do need a strong cooling infrastructure for a supercomputer. From like a size perspective, it seemed like it might be similar to like the data center itself.
Yeah, it felt a similar size. It was quite impressive cooling. These big fans just running air through the radiators was really interesting. So Sam, obviously one of the big things that sets Isambard AI apart from other supercomputers is the modular nature of it. And so, as a final thought, I wanted to know if Emma thought they might become trendsetters going forward. Will Isambard AI become a model that other high-performance computers and AI data centers could be based on?
I think so, absolutely. I mean, the modular data center approach is, as you've heard before, is fast, it's efficient, it's much cheaper than a bricks and mortar building. And heat reuse, the ability to reuse the heats that are generated from such huge infrastructures such as this, and use it to effectively, as you said before, as another utility generator is absolutely the way to go in terms of energy efficiency as well.
Okay, that brings us to the end of Technology Now for this week. Thank you to our guest, Dr. Emma Rose, and of course, to our listeners, thank you so much for joining us.
Yes, and if you've enjoyed this episode, please do let us know, rate and review us wherever you listen to episodes. And if you want to get in contact with us, send us an email to technologynow@hpu.com, subject line modpod. And don't forget to subscribe so you can listen first every week. Technology Now is hosted by Sam Jarrell and myself, Michael Bird, and this episode was produced by Harry Lampert and Izzy Clark, with production support from Alicia Kempson-Taylor, Becky Bird, Alyssa Mitri, and Janessa Ayosh. Our video editor was Leon Roginski-Gorman, and our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett-Packard Enterprise, and we'll see you at the same time, the same place next week. Cheers.
Bye, y'all!